The second case study is about site selection. Public facilities. Companies can profit from a good location. For instance, in Austin, there are many hospitals. If we want to choose 5 hospitals to vaccine citizens in Austin to minimize the total travel cost, how can we answer this question? First of all, we need a population of every census block groups. Then, a base map with geometry information will be utilized to combine the population information, taking the centroid of the census block groups as the representative spatial point. Then, with the geocoding of hospital locations, a Euclidean distance tool will be applied to calculate the travel cost. The final step is using corresponding site selection tools to solve this question, with the arrival of distance and population. Based on these new nodes in KNIME, we can build a workflow for this question easily. In this workflow, we use the US TIGER Map node to get the latest base map at the block group level for 2020 and the US Census data node to get a population. To use this node, users need to request a free US Census API key, which can also be used in another node, the American Community Survey 5 years estimate node. Then, we can combine them and convert the polygon feature to centroids. After the transformation of hospital coordinates, we can get a distance between census block group units and hospitals by using the Euclidean Distance tool. Then, the p-median tool can be utilized to assign the optimal hospitals to each census block group using the 2 key variables. We can compare the result to a random selection based on the partitioning node and the nearest join node. The result showed that the average distance was reduced by 26% compared to random selection, equivalent to a reduction of 484 tons of carbon dioxide emissions if all citizens of Austin drove to the hospitals, which could probably take more than 24,000 trees to absorb it in a full year. If we have a limited budget, we have to select only 3 hospitals. In this scenario, we can change the percentage to 13% in the partitioning node and also set a parameter in the p-median node to 3 and rerun the model. At this time, the results show that the p-median average distance get a reduction of 27%, equivalent to a reduction of 565 tons of carbon dioxide. So, site selection algorithms do help us to save the money and contribute to global sustainability.